Hello, fellow hobbyist game devs. It's taken me a while, but I've finally come back to do another tutorial video. So here's hoping this all is pretty straightforward and easy to follow. So this will be a grid similar to previous videos that I've made, where you've got the accessible grid, but this one is designed to be infinite, essentially. It's a it's actually I'll show it in a second. It's actually a small grid that follows the player around, so that you don't have to worry about having hundreds of thousands of actors um, to display the actual grid. So what I'll do is I'll quickly make a change to the opacity off screen. And this is what the grid will look like. So of it, because I'm mousing over it, it's doing the removing of the opacity, but this is what it'll look like in the background. Once it works fully, you won't be able to tell that it's doing this. So if this appeals to you, please continue watching. So I'm using the the top-down template. I've just modified it, moved things around a little bit, and lowered everything so that it was 0 on the Z-axis. Everything is kind of like in a little bit higher. It starts off at like there. So this is just for my own preference. But if you do move anything in this template, make sure that you update the navigations bound. You can see that by pressing P or going to the show menu and then navigation. Because it's a small bound, when I lowered the mesh that the character walks on, it stopped working, and this character uses the nav mesh. If you decide to not use the nav mesh in your game, you don't have to worry about this, but just for the sake of this example, I'm not changing any settings with the default character movement, so that requires this nav mesh to be here. So I guess we'll start. I started off by just making let's drag it in, a plane in Maya. It was a 128 by 128 units. This is what will be used for the grid. If I put the actual material I've made for it on, it will go invisible. Let's just change that back to, so that's the material. I'll show how to make that in a second. You don't really need to do much once you've got the plane in. You just have to make sure that the collision is set up. So if you click on the little collision up here and click simple collision, you'll see that I've got this little green, let's see if I can turn off the grid. I got this little green box around it. If you're not getting that, or if it's the wrong size, you can just go up to collision, and if you have the option remove collision. If you don't have the option, just go straight to box simplified collision, and that will create the collision box for you. I've had many times I've redone this grid and wondered why it hasn't worked, and it's all because I've either forgotten to set the collision, or I've set it but then I changed the size of the grid and it doesn't update the collision, so I've had a small collision on a large grid piece and it's just not worked properly. In terms of the collision settings over here, because of the way that we're going to be creating the grid, none of this really matters because we will be overwriting all of these settings. So that's not important. But now that we've got the grid base set up, we can create the material for it. So in this example I showed you, I was already using the pre-made material, but let's start with a new one. We'll call it map. Actually, for those that don't know how, right click, materials and textures, material. Sorry, been a while, so I just jumped straight into doing things. I'll do material grid base, and we'll open it up. So the first thing we want to do when we've got it open is on the material domain, the blend mode, change it to translucent. Then what we want to do is for the base color, we want to get a vector parameter and name it color. In this particular example, I will not be referring to the parameter I've set up of color, but it's a good foundation to put in case you want to make it so that grid pieces that have an object on them show up red instead of the blue that I had. It's a good, this is a good ground base because you'll be able to refer to it. You won't have to go back and change the material in the future. So let's just set that to a blue, a whitish blue. And then in the opacity, we want to create a scalar parameter and name it opacity. I always click this little button here to get the full color square. It doesn't make a difference. It's just a visual identifier. So we'll set the default value to 1, and although it's not necessary, I always just set the slide max to the maximum opacity value that I want. So we'll click apply and save, and then back in the grid base settings, we'll just switch that over. Actually, because I've already got 2 materials named that same thing, I'll call it toot matte grid base. So then we go into here, and just to make sure that it shows up, we'll type in toot grid. There we go. That slightly different blue color, but we're good. We're good. That works. That's all we need for now. Cool. So before we start making the blueprint that will spawn in the grid, we just need to do a little bit of setting up in the project settings. So we'll go edit, project settings, and collision. Under collision, we want to, I'll just remove this. Yes. So under object channels, so it's in the project settings, collision, object channels, we want to create a new object channel, and I'm just going to call it grid. The default response, I prefer to put it as ignore. And the reason why I put it as ignore is so that because I'm using it for a very specific purpose for the grid only, I don't want any other blueprints or functions or anything to interact with it unless I tell them to. So having it as a ignore by default prevents any possible jankiness coming up in the future. So once we've got that set up, we can now create the blueprint that will spawn in our grid. So we'll right click in the content browser, go to blueprint class. I'll just call, and we pick the parent class, which will just be actor. I'll call it toot underscore grid setup. And we'll open that up. So it'll be just a blank blueprint. What we want to do is immediately for the variables, create 3 variables. And they'll all be integers. And the first one will be grid x. I could actually delete these. And if you want to quickly duplicate a variable, you just do control. Once you've got it selected, you press Control and W. So one will be grid x, one will be grid y, and one will be grid size. I'll just compile that. So for grid size, in my example, I'm using a 128 by 128 size grid, so I'll make the grid size variable 128. I'll also, just for a default point, I'll set the grid x and grid Y to 10. You can set this depending on what you'll see the difference that it makes changing those numbers a little bit further on, but you could set it to whatever you want depending on how far you want this movable grid to appear around the character. So now that we've got the variable set up, we can go into the event graph. We can get rid of the event tick and the begin overlap. All we need is the event begin play. So what we'll do is we'll drag out grid X and get, grid Y and get, and we want to drag out from event play and get 2 for loops. So 1 for loop, and then we drag out of the loop body and get another for loop. I'll explain what these do in just a second, but first, the way for loops work is they always go from the index 0. So if we have a grid of 10 and we want to do the loop of 0 to 10, it will actually run 11 times because it includes 0. So if we want to get the exact, if we want 10 grid pieces in the X direction, we'll need to subtract a single integer from that, and we plug the grid X into the first for loop. So we repeat that, remove a single integer, and we put that into the last index for the second for loop. So the way this works, for the best way that I can explain, is when this first for loop runs, it'll go integer 0. And what it will do, so this will be the first line of the x-axis. Then it will run this loop the amount of times you have set for grid Y. So it'll say 10 times. So on the first line of X, that way, so on the first line of X, it will then run that loop 10 times up. And then it'll go to the second. So it'll go to the second one, and then run 10, and then the third one, and then run 10. And that's how you get a square grid. You can do some pretty cool maths with for loops like this to get like star shapes and triangles and circles and all sorts. It's maths beyond my capabilities without assistance, but you can get some pretty cool results. So what we want to do is when the for loop runs, we want to do just a little bit of maths work. So we'll get the first for loop, so the X, and we will multiply that by our grid size. So for each grid in the X, it'll go, so it says, since it's 100, our grid size is 128, it'll start at 0, so 0 times 128 is 0, then 128, then 256, then and so on and so forth. And then we want to get another multiply out of the second for loop, and run that to grid size as well. So it'll be work the exact same way as the first for loop, except instead of across the X, it'll go up the Y. Now here's just a little bit of the way I prefer to make grids, and the way that works well for this setup is I then subtract out of both of them. Whoops, can't click the right bloody thing. I will subtract out of both of these results a I get grid X, I get this original grid X minus 1 times that by the grid size, get the grid X minus 1 times it by the grid size, and then we divide that by 2, and then we plug that into both of these negatives. And then what this does is we are minusing half of the grid size from each of the for loops. For a lack of better wordings, this makes it so that rather than the grid growing out, like in the positive x and the positive y directions, it starts in the negative and then grows out. So you get rather than a square growing out from the spawn point, it spawns around the spawn point. So it's like wherever you tell this to spawn, it will be the center of the grid instead of the corner of the grid. I'll once we get it working, I'll remove this from the equation, and you'll get a better idea of why I have that in there. So then I add in a secondary minus integer, and for the time being, I leave that 0. This one is used to offset the grid by amounts to make it line up with the actual game world. So you can see I've just got these two here, and if the grid doesn't line up the way it should, I can offset using these to make it so that the grid lines up, so I don't have to rearrange my whole world to make the grid work. Once again, once I get it working, I'll show you what I mean. So then I put in a make vector and click and drag that for the x and click and drag that for the y. These little things that are created just convert it from an integer to a float. Drag from that, make transform. Now that transform will plug into the node we're going to put, and so we drag out from the loop body for the second loop, and we want to go add static mesh component. And what that will do is allow us to, if you select the actual node, it will allow us to select the static mesh that we want. So I'll go toot grid base, and because I set in the grid base's settings to have the material, the new material we made, it shows up by default here, but you can change it to whatever you want. Now, the thing that we want to do in this particular node is scroll down to the collision presets, and we want to go to custom. Under collision enabled, we want query only, because we will not be physically interacting with the grid. All we'll be doing is tracing and using its location data. We don't need to actually physically touch it. There'll be no interaction. The grid won't be able to block our movement, for example. For the object type, we want to change it to that grid that we created in the project settings. And what we can do here is set everything to ignore and then set grid to overlap. One other thing we do is in the search bar, I type in shadow and we just turn off cast shadow, because this grid will be just a visual showing of the grid. We don't need it to cast a shadow. Casting a shadow, it just creates issues. So finally, we want to make sure that manual attach is off. That way, every static mesh component that gets created will be immediately parented to the default scene route. So when we move this actor, it will move all of the attached static mesh components. If we set this to true, the static mesh components would spawn initially in the correct place, but then when we tried to move the actor would move, but because none of these are attached, they won't move at all. So nothing. It'll look like nothing's happening. So we want to make sure that is unchecked. So that is the grid setup done. What we can do is drag that into our world. I'll set its location to 1, so it's 1 unit above floor, otherwise it'll glitch into the floor. When we click play, there we go. Shouldn't be doing any of this removal stuff at the moment. Let me just disable that. So this is what you should have. You should have this. Okay? So you should be able to see the size of your grid. And if you can get to that stage, you know that it's working. It doesn't have to follow the character or anything. We haven't done that yet. So we just want to make sure that the grid is actually spawning the way it wanted to. Now, if you see here, if I set it to be spot on 0, 0, it'll spawn outwards. So in the positive and the negative, X and Y. If we go back into the grid setup and we remove this section from the calculations, so we'll just set that to -0 and -0. When it spawns, you'll see it spawns in the positive X and the positive Y. And if we are spawning something like this on our character's position, say here, that's just simply not going to work for what we want to happen. So that's why I have that set in there, so that when we play, it spawns around the spawn point. Very useful. You can play with the maths and get it to spawn in all sorts of different ways. It's fun to figure out. At least it is for me. So now that we've got that set up, just checking my notes. Okay, so now what we'll do is I will get started on this. I forgot to prepare this to begin with, so I'll create a copy of the top-down character that I've using that's already set up, and I'll move that into. Oops, I didn't want to copy. I wanted to move. Okay, well I'll just delete this. I copied it instead of moving it, so just forgive me for that one. So we've got the top-down character. I'll delete this one out of the game. I'll move that one into the game. And what I'll do is I'll quickly just off screen delete all of the things I've created so that we can start from scratch and you guys can follow along. Okay. So this is a top-down character. The only thing I've done to the actual character itself is I changed the spring arm length a little bit. I think I made it shorter. I think it was at 800, so I just made it a multiplier of 256. It's just that's how I work. That's what I do. So we'll go to the event graph. Now this is the default top-down event graph. Nothing needs to be changed for any of this. A lot of it is just relying on whether you've got a VR headset or something like that. Yeah, VR headset. I didn't change any of that. You can delete it, or if you're not using VR or whatever, just not necessary. The only necessary part is the parts that it's like where it says, is it false? So down here, the get mouse position in world, the set camera 1 is active. that's all you need. But let's get started setting this up. So the way I've set this up is that you can activate and deactivate the grid with a toggle by pressing the spacebar. If you want to have it running all the time rather than having it to a toggle, you would just create have the grid created on begin play. So you'll just attach it to the end of the event begin play somewhere, and just make sure that that works for you. But what I have it running on is spacebar. So we type spacebar, keyboard events spacebar, and that whenever we press the spacebar, we'll have it either create the grid, or if the grid's already created, we will destroy the grid. So that's what we'll do. I've already got the variables here because I forgot to delete them when I was clearing this thing. So we'll start from scratch with the variables. So what we want to do is, to make it easy for me, the first thing I'll do is I'll create a spawn actor from class node. And for the class, we'll get our grid setup, grid setup. And then out of the return value, I'll right click, go promote to variable. I'll name that reference grid setup. And now that we've got that variable, we can go back to our spacebar and we drag out the grid setup reference, get, drag out of that is valid, and we get the second is valid, which turns it into a node. The first is valid is another way of getting it. It gives you the same result, but this would then be put into a branch or into like an AND or an or something like that. So if you want to use more functionality, you can get that type of is valid. But since we're only checking if this particular item is valid, which means it exists, we don't need to go with the other route. So we'll plug that in on the is pressed. Now, easiest thing to do first is, if it is valid, we want to destroy it. So if it's already been created, we will destroy it. That's a simple part. And then, just for safety's sake, what I do, although destroying the actor should technically clear the reference, I also just set the reference as blank. That's more of just a personal thing. It should still work even if you just have the destroy actor, but I put that in just for my own. It's just a thing I do. So now we go, if the grid setup reference is not valid, so we haven't created this grid yet, we can spawn the grid in. But now what we need to do is we need to get the transform. So we'll drag out from spawn transform and we'll go make transform. Now here comes a little bit of maths on how we can make it so the grid pieces, the visible grid pieces, will actually snap to their correct placing. And that's using a node called division, and I'll explain how that works as we get through to it. So what we want to do is we want to start off by getting the actor location, to get actor location. Then we drag out from that and break a vector to get the X, Y, and Z. So then we drag out from the X and we type in division and we get division, whole, and remainder. And we want to do the same for Y. Division, whole, and remainder. So what we need now is a divisor. And the easiest way to do that is we right click and promote it to a variable. So I will just name this grid size divisor for reference. So we'll compile so that we can modify it. What we want to do is set that divisor to the same size as our grid, which for this example is 128. So what this does, we'll hook this up to that divisor as well. So what this does is it takes our actor's current location, divide it by the 128, and it'll spit out a return value, which is the nearest multiple of 128. So it will always snap to an interval of 128 in both the X and the Y position. And that way, that will make sure it's always lined up no matter where we walk and where we activate it. It will always be lined up with our grid. So what we want to do for this after we do this, I'll make a bit of room. We pull out from the return value and we want to multiply it by a float. And we do that for both return values. And we multiply that by our divisor. So say in the X position, we are 256 units positive. This will divide that. Well, say we're 300, because that's not a division of 128. So we're 300 in the positive. We divide that by 128. It'll be 2 and a bit. If we get the return value will be 2. The remainder will be the and a bit that's left over. So we pull out from the return value, it becomes 2. We then multiply that again by our actual divisor, which is 128. And that will spit out 2 times 128, which is 256, which is the nearest grid interval of where we were positioned at 300. So it will snap to that 256 position and make sure that everything lines up. So now that we've got that, we pull out from there, go make vector, connect the X and the Y, and we can pull out, connect the Z to the Z. Now what I do, if we can just hook this straight up, but what that will do, and I'll show you in a second, is that will spawn it at the 0 position for the actor. So if the actor happens to not be, for example, if we go and look at the left side of this, our 0 point is here, halfway up our body. So what we need to do is work out where our actor's feet will be, because in the game world, their feet are not at the actor's 0 point. So if we spawn this grid, which I should, and I press space, you'll see that the grid spawns halfway up the body. And we don't want that. So what we want to do is just do a minus vector and minus the height of the character. So if we click the capsule component, we'll see that the capsule half height is 96. So its full height would be 96 times 2, 192. But that's all we need the reference for, is what half of that is. So we can minus we can minus the 96, and that will get the bottom of the capsule, and we'll see that his feet are just a little bit below that. So we should be able to just go -6, compile, play, and when we spawn it, it'll spawn at his feet. A lot better. You can tweak the numbers to make it so it is only just off of the floor, because this still looks like it's a few extra pixels or a few extra units above the floor than it needs to be. But without endless tweaking for our uses, this is good. Did that actually spawn where I wanted it to? No. So why is it doing that? I have encountered a small issue. Oh, there we go. I forgot to hook this back up there. So that's what I forgot to do. I forgot to hook that one back up. So now, so what it was doing was, in the X, it was spawning halfway, but on the Y, it wasn't doing the half negative, half positive. It was doing fully positive, so it was only spawning in one direction. So if we click play and press space now, I've broken Unreal Engine for some reason. That was strange. Try again. There we go. For some reason, Unreal Engine did not like that, and it locked up for a second. So there we go. So that, press space to destroy it, press space to activate it, and we're all good. Now, because I would like to make a reference to this value, like this end value here in the future, I will right click out of this, promote to variable. So we'll just add that to there, and I'll call it grid spawn point. So there we go, we got the grid spawning at the nearest interval of 100 or multiplier of 128 with our character's position. So we'll go to the next step, and let's create the calculation that will move the grid back to the character's position once we've moved far enough away from its original spawn position. So I'll create a custom event, and I'll call it center grid. Whoops, can't bloody spell to save my life. So what we want to do is, just for as a redundancy check, we'll drag out the grid setup, get that, and we'll do the is valid with the question mark next to it again. And then from there, we want to draw out the grid spawn point, set. So if our grid setup actor is valid, we want to spawn the grid, set the grid spawn point, and we want to drag out again from this calculation we have and set that. So at this point, it recalculates this, sets it again, and then it's a simple get the reference to the grid actor again, set actor location, and we set that in like that. Easy peasy. Now this function in of itself will do nothing because we're not calling it. We're not calling center grid. So the next thing we want to do is everything from now will be drawn off of the tick function. So I'm going to drag that really far out, and I'm going to drag out of that and add a sequence. So the first output of the sequence will go to everything that was existing here for the tick function. So we don't need to play around with that. We don't need to mess with it to make it work. It will just continue firing as per usual. So the first thing we'll do is, again, for redundancy, we pull out our grid setup reference and get is valid with the question mark. And then we draw out from then1, the second sequence function, and we connect it to is valid. So, and if it is valid, we want to check whether our character has moved a set distance from where the grid spawned to determine whether we realign the grid. So we want to start with get actor location, and then we will do the same negative vector that we did up here. So we know the actor's height is 90, half their height is 96. So we go negative 96. And then we want to drag out our grid spawn point and get it. And we drag out from our actor locations negative vector and minus another vector. And we put the grid spawn point into the second input. Then we drag out from that and get vector length. We get vector length. And what this does is it checks our actor's location and compares it to the grid spawn point and finds out how many units away from the grid spawn point our actor now is. And once they've gone past a certain point, so we want to drag out and go is greater than. And now I'll set it just to 64 so we can watch it working pretty quickly. Then we drag out from that, we go branch, and we go back to our is valid. So if the grid is valid, because if it's not valid, we don't want to try and do any of this calculation. We don't need to. So if it is valid, we draw that into our branch. And then if our actor has moved more than 64 units away from where the grid was originally spawned, we want to call our custom function center grid. So for that, we can compile and save and then play. And what should happen is if we press spacebar to spawn the grid and then we move more than 64 units from where the grid has spawned, it will then update like that. And you can see that it is snapping to each interval of 128 that we have set. So nice and easy, very easy. One thing you'll see, however, is, and this is a perfect time to bring it up, is our grid does not actually line up with the blocks that we have on the map. You can see that the grid actually goes halfway through our blocks. So this is where we go back to what I was saying before in our grid setup, where we had our extra minus integer function or node. This is where we can align it to make it so that it fits to our game world. So because we know our grid size is 128, and visually we could see that the grid was only half lining up to the correct spot, all we have to do is take half of what our grid size is, which is 64, and take that from both our x and the y. So now if we play and we load up the grid and we move to the correct spot, you'll see that it is now lining up. If I can bloody click in the right spot, you can see that it's now lining up properly the way that we wanted to. It's no longer cutting halfway through the grid. So that is a very easy way to align the grid to work with your game world. If you have a pre-existing game world that's set to a particular grid interval, a multiplier, 64, 128, 256, whatever, you can easily modify the offset of the grid spawning to make everything line up properly. Okay, so now we've got the grid recentering as we need it to. All we have to do now is add in the highlighting function, where if you mouse over a particular grid, it highlights it so you know you have it selected, and then when you mouse off of it, it unhighlights it. So let's get started on that. So what we want to do is in our event tick for our sequence, we'll add a pin and get a new pin, and we want to drag out of that pin. I'll just put it down here, and we want to get a line trace for objects. What this does is it draws a line from our start position to our end position, and it will check for a particular object type. I'll start off by adding the object type. So you drag out from the object types input and type make array. Under that array, we've got all of the collision types that we have in our settings, and the one we want to go for is that grid that we set up previously. So this trace, when it draws its line, it will only be checking for things with the collision type of grid. Now we need to get our start and end position. So for this example, we're going to be drawing a line from where our mouse is physically on the 2D plane of our screen, and we'll be projecting that down into the game world. So what we want to do is get our player controller. The player index is which player it is. So if you have two players, player index 0 is player 1, and player index 1 is player 2. Since this is just a single player example, all we need to do is get player index 0. Out of that, we draw out of the return value. Oops, can't spell again. Convert, and we want to get convert mouse location to world space. So thankfully, this little node does all of the heavy lifting for us. We don't have to do any super fancy special calculations. Now, since we want to start from where the mouse is on the screen, we get the world location and we just draw it into the start, drag it into the start. To get an endpoint in the game world, what we need to do is we need to get our world location and we add it, so we get add vector, to a multiplication of the world direction. So the world direction, although it's a vector, the information that it gives out is used to determine the location that the mouse is looking, and then we have to multiply that by the distance that we want that trace to go. So we drag out from the world direction, and we want to multiply that by a float. Now, our characters, so our actual character, their spring arm, their camera, is 768 units. So when our mouse is on the screen, if we want it to reach our character, we need it to be at least 768. If we want it to go further than our character, so far enough to find our grid, it definitely needs to be more than that. So we'll just go with the next interval of 256, or we'll just go with the next biggest number that comes to mind, which is 1024. So we'll go back into our event graph and we'll times it by 1024. And we put that into our end. So what it does is just recapping, we get the world direction, which is where our mouse is pointing, where our vision is pointing. We then multiply that by 1,024 units, and we add that to the world location, which is the actual location of where our mouse is on the screen. So we get the location of where our mouse is on the screen, get the direction that it's looking, draw a line 1,024 units, and that line is looking for the grid. If we put the debug type for duration, and we'll just leave it at its default setting of 5 seconds, if I compile and play, we should be able to see, as you can see, it is doing its best to line trace from where our mouse is on the screen down to the floor. So next, what we want to do is we want to draw out from the return value and get a branch. And all this branch is doing is checking to see if we hit the grid. So if we don't hit the grid, don't do anything. At this point in time, don't do anything. We don't need to worry about it. Only do something if we hit a grid. So we want to draw out from our out hit and get break hit result. And we want to maximize that. And this is where it gets a little bit tricky, because although our grid setup is an actor of its own, all of the little all of the grid pieces are individual static mesh components underneath that. So that, because that's what we added, add a static mesh component. So when we do our line trace, what we want to do is get the hit component from that. So we want to draw out from hit component, and we just check as further redundancy. I like adding a lot of redundancy. It prevents, for me, it prevents a lot of crashes and a lot of unnecessary errors, because if it, for whatever reason, the component that it hits suddenly decides it doesn't want to exist anymore for whatever reason, it won't still be trying to access information that doesn't exist further down the track, and it'll just cut off here. So I like to add in a lot of redundancy. So now that we've got that, so that we know that the component is valid, what we want to do is cast that to a static mesh component. And we go, if it's valid, then we check to see if that component is a static mesh component. And we go, okay, if that static mesh component is valid, we want to promote it to a variable. So I'll name this variable reference selected grid. So that is the current grid piece that we have moused over. So just throwing a little bit extra in here, I will disconnect this and drag this down out of the way for now. But now, because this is an actual component, it won't show up in your basic variables list. You need to find it in the components dropdown, and it will be there. So we'll click and drag out selected grid, select get, and once again, another is valid redundancy check. Now what this one is for is to determine if we have already got a grid piece selected and we go to select a new one, we want to set that old one as being invisible or being a different color, or you get the point. We want to be able to undo what we did to the first grid piece before we select the next one. So if we already have a grid piece valid, one that's already selected. We want to drag out from it and set scalar parameter value on materials. Now this is where we go back to our actual material for it, where we set up the scalar parameter for opacity. So we get the opacity parameter name. Whoopsies, clicked and dragged by accident. And in the parameter name option for that node, we put in opacity. And what that will do is, if our grid already exists, before we select the new grid, set the existing grid to invisible, parameter value of 0 for the opacity, which is invisible see-through. Then we drag out of that and then set our current hit component as that selected grid. Now, if our existing grid doesn't exist, so if we haven't already selected a grid, we can just go, if it's not valid, we haven't already got a grid, our new grid is this. Then, once we have our selected grid, we draw out from our selected grid, set scalar parameter value on materials once again, get our opacity for the parameter name, and this is the one you want to set to when it's visible. I usually just go 0.33. As you'll remember, I set the opacity maximum scale to 1. 1 means that it's fully visible, 0 means that it's invisible. So 0.33 is 1/3 of the way, it's 33% transparent. Now, for a little bit of extra redundancy checking, we can copy this whole bit here, the selected grid reference, the is valid, and the set scalar parameter value to 0. Copy that and paste it, and add for all of these blank falses or failed casts, we just draw into that. So if we're line tracing and we don't get any result, but we already have a grid selected, which is to say we put our mouse where the grid doesn't exist, gets a false result, but we know that we've already got a grid piece selected, we set that piece to invisible. The same thing with if we do happen to get a selected grid or a hit, but then that component for whatever reason ceases to exist, but we do have an existing grid selected, set that to 0. And the same thing, if we do hit a component, but that component is not a static mesh component, we can then do that check again. So we'll compile, save. Now, I'm going to leave the default opacity to 1 so you can see the map, the grid spawn. But as you can see, as I mouse over, the opacity turns to that 0.33 that I set. And then when I've moused off of it, it goes invisible. So when I move around, the grid will follow. I'll turn off that bloody debug line just to make it easier to see. So as we move around, the grid follows, and the grid will highlight and unhighlight as we go. At the moment, there is no, the only thing limiting the distance at which the grid can be highlighted and unhighlighted is the distance I set here for the line trace. So let's just buff it all the way up to a really large amount and then spawn the grid, and you can see I can turn all of the grid, I can access all of the grid as I wish, as I go. If you want to limit how far from the character you can select a grid, I will add that in now, but it is not a necessity. It comes completely down to how you as a player want to be able to access it. So we'll move all this all this here, so from the cast to the static mesh, over a little bit. And what we'll do is we'll add in an extra branch, smack bang here in the middle between the isValid and the cast to static mesh component. And then what we want to do is remove the true. I'll do the calculations first. So we want to get actor location, so get our character's location. And we want to break, we want to do the same thing that we've done previously. We want to get essentially where the feet of the character are. So we take that half of the character's total size away again, 96. And then we want to break the vector. Before we progress from there, we want to get our hit component, get that one's world location. And similarly, break that vector. So once we've broken both of those vectors, we want to... Actually, sorry, we don't need this. We don't need this because I have another way of calculating it. So we just get the base actor's value location and the base world location of the hit component. Then we want to make a vector for both of them, but we don't include the Z value, so it will be at 0. So it will be checking regardless of how tall the actor is or where in the world, up or down, the grid piece is. It will be checking purely the X and Y value. So we want to take minus a vector from vector. And similar to before with the recentering of the grid, we want to get vector length. Draw out from that. Is it greater than, say our grid size is 256, and we only want our character to be able to, on average, access grids 2 pieces away. We'll set that to 256 and then go plug it into the branch. So with this calculation, if the grid piece is more than 256 units away, we want to, in the true, because it is more than 256, we want to drag that down here to set our any previous selected grid to invisible. If it is not beyond our range, we want to set our new grid and set that as to being visible. So we'll compile, play. Now when we spawn it, you'll see that I can access up to 2 grid pieces away, but I can't go any further than that. Depending on where the character actually is inside a particular grid piece, you might be able to access a little bit more. So it can take a bit of tweaking, but for the most part, like that's pretty basic setting up. And with that, you can just go around as much as you want. It'll just constantly update. You essentially can have an unlimited world map size with this grid, and then anything you place will be locked into that grid. So one final thing is we will add in just a right-click function to spawn one of these squares, so that I can show you that all of the grid placement works. So what we'll do is, in our top-down character, we'll just add in a new event for right mouse button. And under that, another redundancy check. We check if our grid is valid. Then another redundancy, if our grid is valid, we also want to see if the grid actor is valid, we want to also see if the grid component that we have selected is valid, because we don't want to right click, it'll then go, oh yeah, your actor is valid, so the grid has been spawned, but we haven't got a selected grid yet, because if you don't have that, it will spawn something at 000 in the middle of the world. It won't. That's what this redundancy is for, is to make sure that it doesn't spawn unless we absolutely know and are sure where we want it to spawn. So what we'll do is we'll draw in a line, add in a line trace, not a line trans, for objects. And what we want to do is we want to get our selected grid again. So draw it out, get, and we want to get that grid component world location. What this line trace is going to do is, for that selected grid component, we want to trace from directly above to maybe a little bit below, or to the 0 point, to see if something already exists there, so that we won't continually place the same block on the same grid piece even though there's already one there. So we want to draw out from our get world location, we will add a vector to a vector. So I'll add this to be 64. So what it will do is, and we'll add that to the start point. So the starting point of the trace will be from the grid we have selected and then 64 units above it, and we'll just trace straight back down to where the grid is located. I'll set the debug for a duration of 5 seconds so you'll be able to see what I'm doing. Then we go object types, drag out from the object types, make array, and for that make array, we set it to, actually what we want to do is set it to world dynamic. And you'll understand why in just a second when we make the actor that I want to spawn. So if, so what we're doing is we're tracing that particular grid piece, looking for a world dynamic, something with the collision of world dynamic. So again, redundancy, we draw out from the return value, type in branch, and then we draw out from the out hit and get break, and we'll expand that. So if we hit an actor with world dynamic, we want to draw out from that. But before I can cast to it, we actually need to create that actor. So we'll go into our top-down example. I'll delete these two, we don't need them. So in our tutorial folder, I'll right-click, create a blueprint class, call it actor, and we'll go toot test block. So all we need for this is we'll leave the default scene root. I'm going to add a static mesh, and for that static mesh, I'm going to add in, I'll type in cube, and I'll mouse over the cubes until I find one that has, in the details you can see there's an approximate size. This one is 256 by 256 by 256. So there we go. Now this is much bigger than our grid piece, which is only 128. So I want to make it just a bit smaller than our grid piece. So 256 to make it to 128 is half, so 0.5. So I'll make it a little bit smaller than that, and I'll make its total scale 0.4, 0.4, 0.4. Now, if we change the view to left, right, front, or back, we'll see that the box, the static mesh is halfway through the ground. So because it's a child of our default scene root, we can just drag that up to make it fit as we wish. And we go back to perspective and it's now above the ground. So all we need to do now is select our static mesh, and in the details panel, under the collision presets, change it to custom. My character is going to be able to walk through this, so I'm going to turn off most of the collision. I want to turn off everything except query, have it set to world dynamic. Actually, is that what I do? Oh, sorry, I want to have no collision. So, no, it needs to be query only. So no physics collision, but we can still get it with a raycast. Set every collision response to ignore, except the world dynamic, which we'll put to overlap. And that's all we need to do for that. So we'll go back into our top-down character. We will drag out from our hit response for hit actor, and we will cast to that new actor that we made, tutorial test block. So if our hit result is positive, it's true, we hit something, check to see if it is a test block. If it is the test block, so if we already have a test block existing, just for example's sake, we will destroy that test block. If we check for something, do the line trace for that grid, but we don't find anything, that means that grid piece is free, which will return a false from our return value because it hit nothing. So we pull out from that and we go spawn actor from class. And this is where we select our tutorial test block. Now from that test block, we do need to make a spawn transform. So the easiest thing to do is we get our world location for our grid piece. We draw out from that, type make transform. The rotation and scale you can change if you want, but we'll leave it as is. And then we draw out, hook that up into our transform for our test block. So what this will do is if we right click, we check to make sure that our grid actor has spawned. We have our grid spawned, but we also want to make sure that we have highlighted a grid component, one of the static mesh components. Otherwise, we don't want it to try and spawn this. Otherwise, it will just create all sorts of hell. Then we line trace to check from just above the grid down to where the grid is to see if something exists there. If something exists, we destroy it just for testing purposes. But if nothing exists there, then we can create something that does exist there. So now we can compile and play. We can spawn our grid, and then we can right click as much as we want. And there we go. And then we can just right click again to destroy. You can see when I destroy, that line trace that I was creating is there. If you want to see it better, we can increase this to say 256. So then when I right click, you can see the line that is creating. So initially, you don't get that little hit box because it line traces, doesn't find anything, creates box. Then when you right click again, it line traces. That little square there means that it found the box and then it destroys it. So one final touch, we go back into our grid base. We change the opacity back to 0, the default opacity back to 0. Just go File, Save All, Play, hit spacebar, create our grid. There's our little grid. The rest is invisible. You can move around. You won't be able to see it moving with you, but you'll still be able to see that the grid is there. You can right click, place things. As you can see, everything lines up beautifully on the grid. You can press space to delete the grid, still run around. press space to enable the grid, and it still lines up. So there you go. This will allow you to essentially have an open world as big as you bloody well like, and you can just have the grid following you. It will always line up. To quote someone very famous, it just works. So I hope you enjoyed watching that. It was a bit of a lengthy tutorial. I don't know if I'm going to continue this grid to make it into anything future, but I do think it's a very good foundation, like a grounding point, a good place to start. You don't have to use it in top down. You can do it in first person or third person. There's really no limitation to how you do it. So I hope you enjoyed. Let me know if there's anything you would like me to make a tutorial about in the future in the comments. And yeah, please like and subscribe if you enjoyed what you saw. Thank you very much. Toodles.